Unlatched Mind. It's 2020. Nuts. My guest today is Dr. Gary Wenk. Dr. Wenk is a professor of psychology and neuroscience. He's a leading authority on Alzheimer's disease and the effect of brain inflammation and the consequences of brain inflammation, I should say. His work, he's been interviewed by Dr. Oz, NPR, CNN, ABC, CBS, and a host of others. One of Dr. Wenk's books, The Brain, What Everyone Needs to Know, was actually on Bill Gates' desk in the Netflix special Inside Bill's Brain. That was too cool not to mention. So, he's really at the forefront of the neuroscience behind nutrition and exercise and what our brains crave and why we crave salt, sugar, and fat, and a bunch of things that are immediately applicable, when you start digging into his work. So really cool. Had a great conversation. I hope you enjoy it. So let's just jump in. So I give you Dr. Gary Wenk. I guess to kick it off, can we give a little bio of yourself and who you are, what your work entails, and what you're passionate about?
Okay, sure. Well, my training began a long time ago, and it was focused on neurotoxicology, essentially the effects of environmental poisons on the brain is kind of where I began. And so I started doing my graduate research on the effects of aluminum. And why? Because it was a time when acid rain was leaching aluminum out of the soil, and everyone cared about it. And aluminum cookware was appearing, so gives you kind of a sense of when all that occurred around the 80s. And that got me started looking at the effects of nutrients on brain function. And for the past 40-some years, that's been the focus of my research. And the other focus has been Alzheimer's disease. And why are they connected? Because back in the early 80s, people feared that their aluminum cans and aluminum cookware was going to give them Alzheimer's. When you don't know what causes something, it's easy to blame it on just whatever it is in your environment that you can't explain. It's superstitious behavior. So that was how I got started into it. And I've been looking at ways to prevent or treat Alzheimer's disease ever since. And obviously, we've all failed. There are no therapies to treat Alzheimer's disease. There have been a lot of claims in the literature, but that's what I've been working on. And over the decades, I've used animal models of Alzheimer's and tested things, experimental drugs, novel, nutrients, spices, herbs, things I got from drug companies. I tested blueberry extract. It's all been focused on ways that we can help the brain, recover or at least age more slowly. That's been the focus. So where are we today after 40-some, or 4 decades for me anyway? We know that Alzheimer's is a disease of lifestyle more than it is genes. And that took my focus back to one important question, which was, what do some people do that prevent their brain from aging so quickly? And the obvious answer, I think, is it's what we consume. It's what we do every day. So that's what led me to the various research projects that I've been involved in. Is what do people do? What do they tell us when we interview people who aged well? And everyone wants to age well, and that's kind of the question that brings people to my book in the first place. Is what can I do to enhance my brain function or slow down the aging process? And that's been the focus of my research for a very, very long time now.
Now, I remember reading a while ago that when they do the autopsies of folks that have died, and whether they died of Alzheimer's or have had Alzheimer's, there's aluminum in the brain. Is that still a legitimate? Is that still the findings? Is that still consistent with what the findings are today?
That's a great point to make. I'm going to build on that.
Okay.
Yes, that is a true statement. And that tends to lead people, those kind of correlations. As human beings, we tend to see correlations as cause and effect, and you have to remind people, well, just because the aluminum's there doesn't mean it caused the dementia. So let's have two questions.
Causation, right? Yeah.
Correct.
Right.
Yeah. So could aluminum building up in the brain cause a dementia? Yes, it can. But for most people, 99% of people out there, it's not going to happen. So we have to ask ourselves, does aluminum collect anywhere else in the body? And the answer is yes. So if you have a heart attack, aluminum collects in the heart. aluminum just deposits in places where there is injury. So there are already injuries in the brain, and aluminum simply collects there. So it did not cause Alzheimer's disease. But for dialysis patients who are being bathed, or filtered with water that may be contaminated with aluminum, we have discovered it can cause what is now termed a dialysis dementia. So, yeah, aluminum has its toxicity. It's rare. Probably most people today don't have to worry about it. And, the least likely place you're going to get aluminum is in your aluminum cookware, which is interesting because we can all see it pitting. But the problem is that it does not get absorbed. And that's the answer to my that I give to many of my students about many questions they ask me. The interesting thing, Vinny, is the question I get most often in office hours is somebody brings in a vial or a pill or a package and they say, I took this last night. What was in it? And the answer begins just like aluminum in your cookware. Well, let's investigate whether or not it can even get to your brain.
Right.
Because we ingest many, many things that never make it to the brain and thus don't do anything to us. So it's the same thing with aluminum. It's the same thing with nutrients in our diet and toxins in our diet. The question becomes, how much did you take, and did it actually get into your brain to do anything? And that ends up mattering more than anything else.
Sure. Yeah, I mean, are you referring to Teflon? I remember Teflon was a big scare for a while. People were talking about
Yeah, Teflon never had issues with brain specifically. It causes, developmental malformations and cancer. I'm not sure that any of them were actually CNS cancers, but it could have. It was a string of 8 carbon molecules with a fluorine on it, which would be what we call lipid soluble. It could have gotten into the brain. I don't remember reading that was a list of the conditions, but it was sufficiently toxic that probably nobody paid attention to the brain. It caused so many other unique cancers but that was one of them. It's a good example.
Yeah, that, and I think I read this a while ago, but it was the antiperspirants containing, I think there was aluminum in antiperspirant. I think that's what keep your pores shut. And I don't remember if that's exactly what I read, but it was like, go just use deodorant. Don't use antiperspirant because there's aluminum in it and Alzheimer's potentially, and so. But
a bad idea.
Yeah.
No, actually. You're absolutely right. You remembered it correctly. It causes the sweat pores to swell closed, which is how it works. It's so irritating. And no, because they swell closed, it turns out we cannot absorb it through the skin that fashion. Actually, we get most of our aluminum from our diet. Meat contains about 1,000 parts per million, which is really high. Cereals, about 4 or 5 parts per million, which is high enough. So we get plenty of our aluminum in what we call a bioavailable form from the foods we eat. The pots and pans and the deodorant don't contribute at all. But so what am I telling you to do? Well, don't eat meat. Well, I could come back to that many, many times. People ask me so often, what can I do to live a long time?
Don't make me end this podcast, sir. Do not make me. You're going to tell me not to eat meat. Well, because I did have some of those questions for you as well. I know you talked a lot about the veganism and vegetarianism, and I'm super. So I don't want to jump ahead in that, but continue because that's. I'm a huge meat eater, and I find it to be more healthy than sugary type stuff. But we'll get there anyway. So.
It is. Oh, you really bring up a great point, Vinny. And I think the best point. Well, what does matter? I mean, hey, if I'm not going to eat meat, I might eat sugar, and isn't that equally bad? I get the same questions. Well, hey, I drink alcohol versus marijuana. Isn't one more harmful than the other? Those are the points that people want to focus on, and they're valid concerns. So, when people ask me, well, what's the best diet? I mean, I'm not a vegetarian. I'm not a vegan or any of those things. My philosophy is just be an omnivore. Eat a little bit of as many different things as possible.
Right.
I have never subscribed to any of these crazy fad diets. And, the old ones like the Atkins diet or the new ones like keto diets. I mean, they're goofy, essentially scientifically goofy things. That get people to pay attention to what they're eating. And if they achieve that, all the more power to them. That's wonderful.
It just seems to not make sense when you exclude any one thing, or you just do all of meat and none of this, or because I know even the carnivore diet is big now, and a lot of folks are claiming that it's helping with their inflammation and and arthritis and other issues, and they just literally eat just meat and nothing else, salt on meat. It's like I don't now if that works for them, they may have an autoimmune disorder where maybe that works, but generally, I don't
Yeah.
think that's what we should be doing. And I'm a big meat fan, so I don't.
I agree with you.
It just
Yeah.
doesn't make sense.
You know, I've talked to some of my physician friends, some of them cardiologists who've tried it, and even they are smart enough to realize it's going to hurt them in the long term. But anybody who's gone on those meat-only diets discovers one thing: they get very tired of meat. They start consuming fewer calories, and they lose weight.
Right.
Voila, they achieved their goal.
Right,
They lost some weight. But their poor kidneys and livers took a beating while they were doing it, you know.
Right.
It is amazing. That's why I think just being a very, an omnivore and is probably healthier than most. It's really all about the total number of calories we consume and when we consume them. In fact, that was just in the news recently. I saw on CNN. That was, I presented this in my TED Talk over about 10, 15 years ago now. It does matter when we eat. We're not just a blast furnace getting energy from our food. It turns out from even studies on humans now, we've seen that if you consume most of your calories in the early part of your day, let me more specifically. Let's say you're on a 2,000 calorie a day diet. You decide to have 1,000 calories for breakfast and spread the other 2,000 out for the rest of the day. Versus somebody who eats 1,000 calories for dinner and very few calories in the morning. It turns out, even though they ate the same amount of food, because you ate it earlier in your biorhythm, you end up absorbing less fat. Your cholesterol levels are lower. Your insulin resistance is better. We have no explanation for why that is, except biorhythms play a big role in how our bodies interact with the foods we eat. Which shouldn't surprise anyone. Eating fewer calories is definitely advantageous, but it turns out that eating when you eat them also has an influence, and I don't think anyone would have appreciated that until recently.
Well, I feel like that was big a while ago. Don't eat before you go to bed because you'll get fatter. And I always just looking at just the law of thermodynamics. I'm thinking, well, calories are calories. Where are they? Is your metabolism like it didn't seem to and it seemed to kind of go away, but so it's interesting you're saying there is actually really something to that, and maybe the biorhythm part is the missing piece to what I was first exposed to it, but that's super interesting. Yeah,
that's true. Yeah, and then even I get that question too. What about eating before I go to bed from my students? So a study looked at this, and it turns out that one of the things about fasting between 6 p.m. and 6 a.m., so you have dinner at 6, breakfast at 6 a.m., is that people would complain, I wake up at 2 or 3 o'clock in the morning and I feel hungry or I don't fall asleep well. So they looked at a study with humans again, and they found out that having a high glycemic, carbohydrate just before you go to bed, not a lot of calories, but 100 or 200 calories of some simple sugar will help you sleep better through the night. Really? So again, you can't have these global rules. It really biorhythm plays a role, and you need to prepare your body and brain. And your brain wants only one food all the time, and that's sugar. And it can use nothing else for energy. So when it turns out we run out, during that time, our liver runs out of glucose or glycogen actually, and we need it. So it was the fact that the study found this wasn't surprising. It was just counterintuitive to everything that you would want to believe.
Right. Yeah, and I know, and I think I've heard, because I looked up some of your material, and I heard you say it a bunch of times, and one thing that I think has been more and more consistent is that just eating less is generally considered, on all accounts, just better for us. And not necessarily because you're going to be less fat, but just I think you had one of the, it was an interview you had done, or maybe it was a summary, I guess exactly, it was a summary interview you had done, there's a bunch of clips, and I think you had said, just generally eating less basically will improve longevity. I mean, it's a blanket statement, but is that pretty consistent with
that captures it? And the question becomes why. We go to insurance companies now. Insurance companies have published mortality figures for many, many years. They care a lot about that. And probably one of the most interesting one and profound and obvious is that the greatest risk of dying is entirely related to how long you've been alive. I love that statement. It turns out,
Okay.
So,
how many actuaries had to come up with that? Yeah.
Yeah, they paid money for that.
Right.
But it begs the question: what are you doing every day that made you get older and get close to dying? Well, the answer is very simple. You ate and you breathed.
Right.
If you could only stop eating so much or breathing so much, we live longer, and that's the essence of dietary restriction.
Hmm.
So it isn't eating 3,000 calories or 4,000 calories a day and burning it off by exercising is not healthy. That's not what the data says. The data that we have collected from hundreds of millions of data points of people over the past decades around the world is that it all is dependent on how many calories you took in. So what we were discovering now from every organism that's ever been studied on the planet, from single cells to us, the same rule applies. Eat less food. Take in fewer calories. You will age more slowly. Will you live longer? No. There's no such thing, as far as we can tell, of living to 100 or 30 or 40. That's not going to happen. But will you probably live to your own personal maximum for whatever your genes have laid in front of you? Yeah, you will, and you'll be healthier. Yeah. I did these studies on rats many years ago, and my God, they didn't get cataracts, they didn't get gray hair, they didn't develop tumors, they maintained some of their cognitive ability. It's, that's the key. And we're beginning to unpack the reasons why that happens. But the rule has never changed, and the advice is still the same. Eat, and people ask me this, how much less do I eat? Well, one thing is just skip dinner. Is one way to look at it. Eat a big breakfast. Oh, on my TED Talk, I put it as breakfast like a king, lunch like a prince, dinner like a pauper. And that will get you probably the longest life and the healthiest one you can have. And notice in there nothing about meats or high acidic or low acidic foods. It has nothing to do with that. Right. Those are gimmicks. There's no science. But if it gets you to eat less, believe whatever you want.
Right. Yeah. So what the whole, I have a little quick personal story on the eating less thing. When I remember this was way back when, just before when we had kids and I was doing life insurance and, I considered myself, almost super fit. I was doing CrossFit every day and it was kind of the peak of my fitness. And now I was always a heavier guy, not necessarily body fat heavy, but just heavier. I lifted a lot of weights, but I could also run a super fast, fast for me, 5K, and I considered myself generally very fit. So I was thinking when I would get health insurance, I would get the best of the best rate, and it would be, it wouldn't even be a question. And I got, after they do some testing and all that, I ended up getting like the second to best rate. And I was just floored. I was like, and I gotta be honest, the insurance company was excellent about it. They walked me through it. They had their actuaries call me, and they're like really smart people. And if I finally got to the right conversation with the right person, and they said, to be honest, a higher BMI, whether it's crap or not, is debatable because certain people are considered obese when they're just big, heavy or muscular. It doesn't really account for that. But generally speaking, the actuaries were saying, if you're a larger person, you consume more calories every day, they don't really care how fit you are. You're generally going to have less longevity. So I'll never forget that. And then they didn't get too specific, but I never forgot that. And I started researching it. This was 10 plus years ago. And it was just interesting. And I remember hearing that was the first. So what you're saying is spot on in terms of what their beliefs and what you're saying is completely in line. And it was just, generally speaking, if you're a little bit of a bigger person, whether you're muscular, fat, they don't even care. Just you're probably consuming more calories to maintain whatever you got going on, and it's less healthy than just being someone who's thinner and eats less and just kind of eats when they get hungry and doesn't really care about food. And so it was interesting. I live to eat, so for me it's different.
And unfortunately for you and I, Vinny, we're both males. Males of all species, you, right? Whether you're a fly or a human, we die faster thanks to testosterone. Yep. It's all tied entirely to why you need to eat all those extra calories and the fact that you have muscles. They're full of these creatures' mitochondria, and testosterone allows our mitochondria to waste energy as heat. And so men are always warmer, and that's why all males, even if you're a fly, if the males live 5 days, the females live 7. It's astonishing. The rule holds no matter what. And we used to blame it on reckless behavior by males, but has nothing to do with that. It's just if we weren't warm. The interesting thing that happens to people when they start taking in fewer calories, and men notice this and complain first, is that they feel cold. And their wives have been complaining about that forever. Then men, when they begin to lose, start eating less, they notice it too. and then they end up living longer. It's really interesting.
Now,
well, they gave you some good advice.
Yeah. Unfortunately, I didn't get the best rate, but I did pretty well. But I was a little, I dug into them, and I got to be honest, they did a great job of just listening, dealing with me and just walking me through the process. And I finally got to the person. I actually said, "Hey, I really appreciate it. This was days of you guys talking to me and giving me information." And I asked him, I was like, "Can you just come over here and watch me run a 5K?" Like, I was trying to I was asking him to give me tests. Like, this guy's insane. But
prove to me that I'm not healthy.
yeah, exactly.
I see that all the time.
Yeah.
So my 19 to 20-year-olds, they're incredibly active, and but I warned them, but they're not going to listen,
right.
And neither would we at a certain age.
Yeah.
Anyway,
exactly. Anyway, so a question I wanted to ask you too, because you kind of open up your, a bunch of your blogs with, and I think this was the blog on Psychology Today. We talk a lot about food, and I think you draw a lot of corollary to food versus drugs. What is the difference between a drug and food from our body's perspective, or from our brain's perspective, I should say?
Generally speaking, there isn't any difference. If you were to miniaturize yourself and sort of stand next to an individual neuron, you wouldn't notice a big difference, because let's define the word nutrient. A nutrient is something that your body or brain, focus on the brain, that an individual neuron in the brain needs to survive. Well, the brain's primary source of nutrients is sugar, glucose. In fact, our brain uses so much, it's the equivalent of about 12 donuts a day. So it's a lot. It does need some specific amino acids and some specific fats and so forth. But primarily, it just burns a lot of sugar. We have a very energetically demanding brain. And the unfortunate thing about all that is, when we were just discussing how you live longer if you don't eat as much. Well, our brain eats a lot of calories. And the brain doesn't possess the defenses, the chemical defenses that the rest of our body does. So it tends to suffer for that high energy demand. But essentially, nutrients essentially bring carbon energy to the brain, to individual cells. The energy between two carbon atoms. That's the energy that we gobble up that's what we call calories. And from the brain standpoint, a sugar molecule or a molecule of heroin is just a string of carbon bond energies. However, obviously, they do different things. In addition, there's a next level of how they interact. So sugar is just going to be, ingested by the neuron and used as energy, whereas heroin ultimately will be. But initially, what it's going to do is convert itself to morphine and act to produce, specific responses in the brain. So what does a drug do differently? Well, drugs go into the brain, they find specific protein receptors that they bind to, and they produce effects in how the brain functions. So it may be a hallucinogen, a drug that produces euphoria, a drug that produces analgesia, loss of pain, or an antidepressant, or any of these things. They are defined simply as a molecule that's going to produce an effect in the brain that we desire. Nutrients get into the brain in adequate concentration, but don't interact with neurons in the same way. They just provide energy, or maybe a precursor for some function. That's the main difference. And it has everything to do with how much got in the brain. So we are constantly consuming chemicals that can cross the blood-brain barrier, could interact with our brain to produce changes in mood or thinking ability, but don't, because the doses are too low. So it takes a certain amount. So when you go to your local pharmacy, you pick up an over-the-counter drug, it's already been measured out to give you the effect you want. But, you get street drugs or, illicit drugs, you don't have that promise. So, again, it all depends on how does the brain interact with a particular neuron, and is it there in a high enough concentration to do anything? So, we depend on our pharmaceuticals from the pharmacist to be at an adequate concentration, to do something that we want. And we accept from our molecules the risk they bring. We all know that eating too much sugar or fat is critical for survival, but it brings a risk of obesity, inflammation, diabetes, and so forth. We all know that taking aspirin is going to relieve our pain and reduce our fever, but it's going to cause GI bleeding, and it's going to have some other secondary effects. So nothing is without side effects. Nothing is out without a cost.
Right.
And as I tell my students, you sort of have to look at your molecule that you care about, aspirin, heroin, sugar, fats, whatever it is, and say, what do I want from my molecule today? And what am I willing to accept as a cost, the side effects?
Right,
you know,
right.
Am I willing to accept the GI distress, the bleeding? Am I willing to accept the legal consequences? Am I willing to accept a little, a little body fat and inflammation if I enjoy this second brownie or cookie or whatever?
Mm-hmm.
You can see, and that's the negotiation we make with our body and brain every day. What do we want to benefit us, and what are we willing to accept as a risk? And that feature also defines what we consider to be a nutrient or a drug. One of the best examples of this is chocolate. Chocolate contains a lot of psychoactive agents. It contains something like marijuana. It contains amphetamine-like compounds. It obviously contains sugar. It contains a xanthine, like is in coffee, caffeine. And for most of us, we consume it and we enjoy its sweetness, the fat, and it's just calories. The level of those chemicals in chocolate usually don't reach a level that actually affects our brain, unless you happen to be somebody who suffers with a disorder you've never heard of called chocolate anger syndrome. After I wrote the book, I had a number of primarily women write to me and say, that's me. My doctor was never able to diagnose what that was. This is the hidden element in our discussion, which is your genetics. Some people inherit from their parents a genetic vulnerability to respond to the ingredients of chocolate, and produces an aggressive anger that just really bothers the people who suffer with it. And after a while, they figure out it's definitely chocolate, but they just don't know why, because no one they know suffers with chocolate anger except them. And, they can't figure it out. So it's an interesting example. So some people have genetic vulnerabilities, things they inherited from their parents, that make them more vulnerable to a nutrient that now becomes like a drug. And it baffles them.
What in the chocolate is causing that? Sorry, but what in the chocolate is actually?
No one knows.
Oh, really?
That's a really good question. It's like marijuana. It is an aggregate effect of multiple chemicals from a natural product. The cocoa powder that's in it probably contains a variety of things. Plants tend to make, lots of, we call it their secondary metabolome. It's chemicals they make that they don't need to grow and survive. They make to defend themselves from bugs. And so a lot of those things have become very interesting to humans. The contents in the cocoa bean are there to defend the plant from being eaten by bugs. Marijuana actually is placed in droplets on the surface of the plants, the cannabinoids, to defend themselves from being eaten. Plants do this. Cannabinoids show up in lots of species of plants. Nicotine is in 70 or 80 different plants. Psilocybin is in at least 75 different mushrooms. But, we stumble onto one of them, like for the tobacco plant or the magic mushroom,
right.
And it becomes everything to us. But the truth is that Mother Nature creates these things for the plants to defend themselves from being eaten and from being overtaken, being eaten by animals or insects or whatever it is. And sometimes we stumble onto them and find that they act in us because we share an evolutionary history with these creatures, and so we have the same receptors in our brain and body for them.
Right.
I mean, bee stings wouldn't bother us if we didn't have the right receptors. Bees inject us with serotonin to help dilate our blood vessels to get their toxin into us, and it goes on and on from that. It's interesting. Resveratrol has been in the news a lot. It's in the skin of red grapes, and essentially resveratrol is an antifungal that grapes make to defend themselves from fungi. And we eat it, and it does different things in us. But so that's all they're there for. And anti-inflammatories are very, very common in nature, which is an antioxidant, which is why we're always telling people eat lots of fruits and vegetables, because they contain natural anti-inflammatories and antioxidants. And there's only one reason you need them. You need to defend yourself against the oxygen you're breathing because you're eating every day.
Right.
Yep. You can see how we just wrap this around.
Yeah.
So what's the advice? Defend yourself from breathing, because you must breathe to digest the food and metabolize it to get the energy that you need to survive every day. And because you breathe, every day and eat every day, you get a little older every day. And the longer you are alive, the more likely you are to die. You can see how it all comes around.
You just
Very
close
simple,
that out
doesn't
nicely.
it? You know?
Yeah.
It takes a lot to unpack it all.
Yeah.
But you can see where all the advice comes from and what people try and do. And it's just us, us and the plants out here trying to survive a little longer in the environment that we're in.
Yeah, well, it's amazing, So we just, like you said, we just kind of went full circle and unpacked a lot of the biochemistry of what makes you fat, what makes you high, what makes food taste good, what your brain craves, and there's a lot of I feel like there's a set of, like, I don't know, a small set of just absolutes and rules, and then you look at what marketing and what the open market is created with. There's a new fad every few weeks, and we, as I guess, it's amazing how we just continually chase. It's almost limitless, the things, whether it's workout regimens, new pills, new supplements, new diet fad, and it's almost like, if you just take a step back, maybe listen to this podcast and listen to others and go, oh, wait a minute, it's all pretty much just different ways for other folks to make money. And a lot of and I think a lot of them sometimes do work a little bit, because, like you said, they have all these side effects. If you just eat less, if you're just eating all meat, well, you're going to, I guess consuming no sugar is going to be probably going to be good in general, maybe. But can you eat a little sugar every day and be fine? Sure. I mean, I think sure, right?
Sure.
And you're going, like you said, you're going to eat.
And from the brain standpoint, you need it.
You need it, right? Yeah. I mean, and that's actually, but it's funny because it's like you do end up eating just less calories, and because I always go back and forth with that. Is it just about calories? You really have. I feel like there's two camps out there where it really just is about calories in, calories out. And I think I read what was the book, the Obesity Code, I read by Dr. Fung, and I actually thought it was very, very well written. And if I remember right, his stance was that it's really not about the calories; it's all about hormones. And my takeaway was,
no, he's wrong.
Okay, yeah. I mean,
I'm going to sound terribly arrogant. I've spent 40 years teaching
this is why I brought it up.
what they know about the brain.
Yeah, that's why I brought it up.
And it's like, I read so many books by MDs that just frustrate the Jesus out of me. I now warn my medical students, please don't write anything, or I'll come and find you and beat you up myself, even out of my nursing home. We don't teach them enough, is the truth, about the brain. And there's a simple reason, and they go out and write these books, but there's a simple reason for that. We don't know much about the brain. Nobody's going to walk into their office and say, my right amygdala just failed. And they're going, what? How do you know that? And where the heck is it? It's about 2 inches inside your ear. Because, first of all, there's no real symptom they would know,
right,
and there's nothing the doctor can do about it. So we end up spending most of our time teaching docs about the brainstem and how to find the lesion, the tumor, the stroke.
Right.
And then what's never asked, and we never tell them in med school, is this is what you do about it, because there isn't anything you can do about it. The neurons are dead. Just to help the patient recover, send them to a physical therapist and hope for the best. We have nothing. And that's actually the basis of the point you just made. Why do people turn to fads? Why do people turn to these crazy theories? And the answer is simple, because we have no good alternatives for them. If you come down with a diagnosis of something wrong with your brain, there is no solution, sadly. We don't have effective antidepressants. We don't have good antipsychotics that don't have terrible, side effects.
Sure.
They're not therapies. They're not treatments. We cure no one. These are Band-Aids. And these poor patients live their lives suffering through side effects. And, is somebody who's taking an SSRI no longer depressed? Ask any of them, and they'll tell you, no, I still feel anxiety and worry and many of the same symptoms. I'm better, but I'm still not cured. Right. This leaves the door wide open for charlatans and people to come up with goofy theories of a hormone here or a protein there, or it's casomorphine out of milk coming through leaky guts, and it's because there's no good answer. People go looking for goofy ones, and there's always somebody out there to sell them. That's the key thing. A product.
Right.
Is it going to hurt them? Probably not. But it won't help them, and it may delay them from getting actual treatment that could help. That's the only real downside. It's like the anti-vaxxers today. Our vaccines, Might the occasional child interact badly? Sure. You could take 1,000 children and inject them with sterile saline, and you'd have one or two that would react badly. But that doesn't prove the point. We don't have statistical minds. So if we hear that some child, one, out of all the children you might know, reacted badly, that's good enough. And we'd like to think that our physicians are immune to that. But study after study has been shown that when you interview physicians, they're greatly influenced by the last patient's bad reaction to a drug. Even if the 100 before them responded well, if that last patient didn't, they report more hesitance to use it. Why? It worked for 100 people, but we're all vulnerable to that kind of thinking. This is why we have statistics, is to try and get around that, so we can give people some assurance that probably for you it'll work. That's the FDA's promise. Generally effective, not always, just generally effective and generally safe for people who take it, a particular drug. But there's no promise. That's where we are today. And so this is why those fads appear.
Yeah, and I guess, to be fair to the folks out there that may be writing the books or selling a product, some of them may actually believe and have done the research and feel they're onto something, and then, hey, why not also make money in the wallet, and then I'm sure there's others that don't even believe it themselves. They found a million holes in the data, and they just just buy this new machine. If you do crunches this way, you'll have better abs. When no, actually, you have 7 layers of fat. You have 7 layers of fat over your abs, but making your muscles stronger under them is not going to make them show.
They're beautiful abs.
Yeah, we all have abs, don't we? If we take the fat off, right? Yeah. I have an 8-pack, but you just can't see it.
That's true.
Yeah.
There you are.
Right. I always said,
and I think they do believe it, as is true for any true believer in those things. They do believe it, and that matters a lot because of the placebo effect. One thing I always like to teach my students is placebo effect is very good for 2 things in humans and animals: pain relief and mood improvement.
Right.
The other thing about placebos is that they're fast. Drugs are never fast, real drugs, but placebos, tomorrow you're going to feel better. If someone tells you that, you take this pill and tomorrow you're better, it's a placebo. And it's always about pain and mood, because everyone suffers from pain of some kind or anxiety, depression of some kind in their lives. We don't have a brain that works like we're always euphoric, and everyone wants relief from it. So placebos work. And if the patient believes because, the whatever goofy practitioner has told them, and they believe the practitioner, then all the better. They're going to benefit.
Well, that always
and
fascinated
they won't
me.
have side effects.
The placebo effect has always fascinated me. You tell someone you're going to feel. I mean, how does that really work with the brain? What is the brain doing that actually? Is it just taking the information that it expects to feel and makes it actually happen? Like
it should. That plays a component. It turns out we've only understood what we now call the placebome, which is the genes involved that you inherit to enhance your placebo effect. It turns out that some people, and we've known this for a very long time, some people respond to placebos way better than others. And it's always a certain percentage of the population. And the question is why? Well, now we understand that there is a set of genes, and at least a dozen of them have been discovered. And at least 10 of them, I think, are related to brain function. And they are related in ways that kind of make sense to us now. So if you inherit these particular genes, you will probably have a bigger placebo effect than other people. And you're going to be one of those people who say, wow, I took this magical Chinese herb that, is green and ugly and smelly, and it really helped me, and I'm better. And I use that example because it turns out that with alternative meds like this, they need to be strange colors and strange doses and strange taste, because all that contributes. In America, you will never walk into a pharmacy and come out with a black or brown pill. Americans don't like black or brown pills, so they don't make them that color. But in Europe, they do. Americans believe that little white pills are safe. Therefore, all the over-the-counter pills are white usually. We believe that red pills are more powerful than blue pills. So if you go in for anti-cancer drugs, they tend to be red. If you go in for pills to help you sleep or calm you down, they tend to be blue or pastels. That's part of the placebo effect. If you're told to take a drug every Thursday in a full moon, you're going to think it's more powerful if you believe in that kind of thing.
Right.
And herbalists and these practitioners, they take advantage of that. Chiropractors do the same thing. They'll bring in fancy equipment with lights and buzzers and move your arms and limbs around, and if you're in pain, you're probably going to feel better if you just spent $95 for this person.
Right.
and you believe them. My experience is that they just, I remember the hospital I worked at once, they got one chiropractic injury per week. From chiropractors hurting people, they're not well trained, but if you believe it, it works. And that's, the Tinkerbell effect is powerful in us. You just got to believe.
Yeah. No, it's interesting though what the brain can do. I mean, you can actually make a headache somewhat go away if you take a pill that's just got sugar in it or something, and someone told you this is the best headache pill on the market. Your headache gets a little better. It just fascinates me what your brain can do. I mean, it's just.
Oh, it is.
Yeah,
we learned it in the wars too. It turned out that these studies were done. Soldiers in a battlefield who get shot and know they're going to be taken home now, away from the battlefield. They're alive. They're going home. Need fewer painkillers than people who get shot in a similar way in the streets, who now have to worry about who's picking up the kids, who's getting the laundry, how am I going to miss work. All those things that your brain contributes and piles on to the pain makes pain worse, and we need more therapy. And people who live in impoverished, poor environments don't need as many antidepressants, and they respond better than wealthy people who go to, wealthy clinics or hospitals. It's expectation about what they're going to get. And so it plays a huge role in medicine. And so we can't ignore it. So, you just got to believe.
Tinkerbell again. So are there one thing I had a note here as we were talking, speaking of snake oils and charlatans, are there any actual supplements out there that help with cognition or memory? I mean, you hear these nootropics and there's all these other things and my top level looking in from a layman's perspective is nothing really does anything, but are there anything real out there that, you would advise?
No, not at all.
Nothing at all.
Not at all. No. I spent at least, a good 10 years working with the nootropics. They've been around a long time. The company that invented them is long out of business, and some American companies have tried and failed. The interesting thing about a lot of them is they don't even cross the blood-brain barrier, which was frustrating. It was like, wait a minute, it's not even getting into the brain. So there was no surprise that they didn't do anything. But usually the good advice is that even the ones that do get into the brain don't seem to do any harm, as far as we can tell.
Right.
But they're a molecule in search of a purpose, and we got a lot of it out there. They made a lot, and people are trying to find ways that they think it'll work for something. So maybe one day they'll find a use for them, or that class of compound. A lot of drugs are made and then put on shelves and then are famously rediscovered. Valium and Librium back in the 50s and 60s is an example. It had been invented, I think, in maybe the 20s or 30s, and no one ever tested it enough. And it was only until a guy named Hoffman tested it. No, a different name. Doesn't matter. That was someone discovered that, hey, this actually might be useful. And sure enough, lots of benzodiazepines were invented from that. So, maybe they will be rediscovered for some purpose, but not yet. And we do not have anything, which again is why there's so many claims out there about that's easy claims where you can just say, well, take my magic elixir of herbs and vitamins and you will be better. You will be healthier. And if you believe it, you will.
Right.
It's pretty easy.
Right.
But no, there is nothing. And until there is something, people will just keep buying, nonsense and paying a lot of money for it.
Well, they will. And I was thinking about that, if someone listens to this podcast and you really do your research, you're probably going to find all the same, truths that you're kind of explaining. If you really read it, right, and you try to stay unbiased. But I don't think that's going to change many. Maybe I'm being skeptical, but I think we all want to believe certain things. We want to believe if we eat this exact way, we'll be in the best shape of our life, or if we buy this equipment, we'll be in the the most fit of our life, or I take this pill, I'll have a better memory. Like we all want to be better at everything, and it's I think it's hard to accept that it's pretty boring to get there. You're going to have a genetic limit to whatever it is you're trying for, and hard work and moderation with diet and other things is really the only thing you can do. It's just kind of a boring concept. Like,
Isn't it
is
though?
like it just bores the heck out of me to accept that as a reality. But
flip it on its head, though. You can say, look at all the money you're going to save by not buying all that food.
Right.
All the gym memberships and gym, yoga pants and tennis shoes that you won't have to buy. Just go out. You're right. Modest exercise, a nice long walk, that kind of thing is really good. I just finished writing a book for Oxford, Your Brain on Exercise. And it's not an exercise book. I am not an athlete, but it essentially is like, what does exercise do for the brain? And I thought it would be a simple story that was straightforward, and it turned out to be anything but. Muscles are almost like an endocrine gland. They are so complicated and interact with the things that we eat and drink, and and obviously affect how we age and how the brain functions. And so it turned out to be a fun write. But that's it exactly. I think we just move a little. It ended up being very boring advice.
Yeah.
But on the upside, it saves you money, and you have plenty of time now to do other things that might enhance brain function. But until we have something that really works, people are going to be vulnerable to all these charlatans. And it's. Is it sad? I don't know. If people feel like they're getting better, isn't that good enough? That's what I hear all the time.
Well, that's true. It almost, yeah. If you look at, you want to just keep the absolute truth in the forefront and highlighted, then it kind of hurts your head a little bit because people are just kind of being taken. But you're right. Are they being taken if they do feel better and they do feel good about ignorance is bliss, sort of? You get back to that cliche in a sense.
It is. And if you feel better, then what's
that's
the harm?
Point, I guess, right?
Right. I hear that all the time. Yeah, and I have a friend of mine who he won a Nobel Prize a number of years ago, about 10 years ago now, and he didn't know what to do with himself. After that, I was like, what do I do now? And he just decided to start hawking on the internet vitamin supplements, and it was like, oh, good grief. But if a Nobel Prize winner, and he's a really smart, pleasant guy, but if a Nobel Prize winner tells you that this vitamin mixture is going to make you smarter and live longer, you're probably going to believe them, and all the better.
Yeah.
If you believe it'll work, it will. And generally they won't hurt you. I mean, we listed some examples here, like the Atkins diet and things that may hurt you when you're all protein, or the paleo diet, which really isn't, and even though the ketogenic diet is, I think, healthy ordinarily, it's not going to change your blood pH, thankfully. Otherwise, people would be dying from it, and they're not, clearly.
Right.
But the science is always goofy, but sometimes the diets are okay. They're not harmful. They tend to emphasize fruits and vegetables, and that's great. But they never really get into saying eat fewer calories, which has been shown over and over and over again. But our brains evolved under conditions that don't exist today. Our brains evolved under conditions when food, especially fat, salt, and sugar, were scarce. When our ancestors in Northern Europe found a salt a deposit, they settled there. And all those cities today in England are called witch, like Greenwich and Norwich and things like that. That means that was where the salt was located. So people lived there because it was a salt source. And if you killed an animal with fat, there was plenty of great tasty fat there. And fat is a wonderful source of nutrition. A lot of great calories. And if 10,000 years ago, that meant you were more likely to live, and so were your relatives. So fat, salt, and sugar were vital, and sugar just simply never occurs naturally. You're just never going to bump into sugar. So our brains evolved the ability to reward us to eat to completion whatever we find when it's fat, salt, and sugar. So studies have been done like this with smorgasbords or family gatherings when food's out. People will eat putrid, ugly-looking food if it means they will keep it from someone else. So if there's one last deviled egg on the table and there's a fly sitting on it, but you see Uncle Harry going for it, you're going to run over there and get it ahead of him and shoo off the fly and eat it. It's built into us to eat those things to completion, because up until 100 years ago, it was critical to do so for survival. And so our brain rewards us for that kind of behavior. And now today, it isn't survival, it's just money. And so we find fat, salt, and sugar, and we will just eat it, and our brain will say, thank you, give me some more, which raises a really interesting feature of our brain. when people use drugs of abuse like heroin, or they take in a big piece of sugary fudge or something, they get this ephemeral pleasure. It's brief, it's intense, and that's the way our brain rewards us. I don't know if anyone's ever noticed, but real pleasure in the brain is ephemeral. Orgasms, ephemeral. The taste of a wonderful wine, ephemeral. This is how the brain works. So the drugs that we find that are drugs of abuse usurp that ability and make that ephemeral euphoria last longer. Because, I mean, no one sitting listening to us talk is sitting there in abject euphoria right now. We just don't exist in that condition.
I beg to differ.
Our brain waits into, you know what I mean?
Right.
We wait. Our brain waits for the fat, salt, sugar.
Right.
It waits for the orgasm. It waits for the heroin. And then it's like, wow, that's the limit to which our brain can reward us. And then it's gone by nature. It's how our brain evolved to become, so that we would go, wow, that was great. I want to do that again. Get me some more fat, salt, and sugar. Get me another mate for orgasm.
Right.
Our brain has only one goal: our survival and the procreation of our species. So fat, salt, and sugar and sex are all our brain rewards us for. And there you are, our addiction.
Right.
You know?
Well, no, it's because I think that was in one of the summaries of one of the, I think it was on Amazon for your book, your Brain on Food, right? Named the book, your book. You did say, why do we crave fat, sugar, and salt? And I think that's what you just articulated. Because for me, it was always, I always thought, and you forget about our history, but like I would think, well, I guess we should do things that would increase our survival, right? And today, 2020, eating to excess fat, sugar, and salt, it's having the opposite effect, right? We're dying. Aren't we dying sooner because we're more obese because we can't stop eating? So it's like our brains haven't evolved to our current reality that we can just get food whenever we want it, right?
They haven't caught up yet. Correct. Yeah. And so the alternate irony, of course, is that eating fat, salt, and sugar all the time leads to metabolic syndrome, then diabetes, and diabetes puts us at risk of Alzheimer's and brain dementia.
Yeah.
So the very behavior of our brain, it's kind of ironic, but it gets complicated when you look at how all the ways that these things interact. And exactly, our current culture complicates the rules that our brain evolved, to behave under.
Right. Yeah, I mean, that's in essence, that's really it, right? And it's taken me a while to kind of put these pieces together, but talking to folks like you and others, it's like about other things, not just food and drugs and whatnot, but it is interesting how quickly technology has vastly outpaced our genetic adaptation. So we're in this weird state where, and I don't know what the future is going to be, but to our example just now, you know what, we've evolved to do certain things to survive and focus on procreation and survival, but now the entire foundation, on which that evolution had happened is now changing. I can go down. I mean, and most of we're very lucky in the United States where it's poverty is pretty scarce. It still exists, but pretty much no one has to go hungry in this country, which is an amazing thing. So and then I don't care. I'm blessed enough where my kids want some snack, we just get them a snack or get them. We never miss a meal if there's So our bodies are just not, I don't think, used to that. And excess is just a button press away. And food is so cheap, and usually the cheaper it is, the crappier it is for you. And it's just like, it's tough to. I don't know what do you think is going to happen as technology is only getting better, things are getting more efficient, but I'd hope we don't just continue getting more and more gluttonous. But I don't know.
I think I have a thought on that, and it's not pleasant. Well, actually, before I say that, I have colleagues in neuroscience who are working on ways that I think in the next 50 years, your children and certainly their grandchildren will see develop. And that's the merger of our electronics into our brain tissue itself. We haven't been able to do that because of the behavior of living tissue next to metal. But that is slowly being overcome. And I think we'll see a merger, much like the Borg on Star Trek, where we start implanting things and they become naturally part of us and enhance us. And, we'll be communicating in different ways, probably. That's an easy one.
I know Google's working it. Yeah.
I can see it coming.
Neuralink, Elon Musk is working it. Yeah, there's a lot of companies working it. Yeah.
But then we'll have all knowledge available to us at all times, and then nobody will have an excuse to say, well, I didn't know, nicotine would harm me or something, right? But I think long before that happens, we can see that global warming is going to affect how all cultures affect us, are affected by it, rather, around the planet. And I think, one of the things that's going to happen is there's going to be a shift in the population, a shift in our ability to grow crops. One thing that my colleagues in climatology tell me is that in spite of what you hear in the news, it's already too late. That it's going to happen now. There's nothing we can do about it unless we can figure out a way to build the technology to literally remove the carbon dioxide from the air, which we don't have. So it's already too late. They believe we're past the tipping point. You just sort of, government should just get ready for that. So I think, sadly, the ability to be a gluttonous nation and to have all food available at all times is going to slowly be taken from us because of the changing climate on the planet. And there will be consequences. I spent my entire career trying to find a way to alter Alzheimer's disease, a disease of the aged brain that happens in people when they typically get to 60, 70, 80. Many people live to that age now, and so we see a lot more people with dementia. The expectation now is that 50 to 100 years from now, dementia won't even be a problem because so few people will live that long. So it doesn't matter that we haven't cured Alzheimer's because it may not even be an issue for a very, very long time. My colleagues tell me that when global warming comes, the Earth will heal. It will come back. Things will swing around again. But it may take between 5,000 and 10,000 years for that to happen. So I think the problems that I have spent my career focusing on are going to become moot for a very, very long time. And I think these issues that we're discussing may become moot as well, because I think gluttony won't be the problem. Diabetes won't be the global issue that we feared for many years. I think it'll just be getting enough calories. That's my fear. That's sad, but it's just a consequence of what is going on the planet. And we know enough from anthropology and looking back at the history to understand what will happen and how it will happen. I think we're smart enough now. What we lack is the ability to prevent it. And I think we may need to have computer-enhanced brains to figure out the problems, novel ones that we will face, that our species has never faced, or at least not for a very, very long time. I think that's the very depressing kind of view, but I worry that's the future.
Well, that's
and we may need a smarter.
Yeah, it's quite dystopian. So you really, in your, well, if it's, so are you really saying you think global warming will contribute to basically an entire change in how we humans can, so we are actually going to live less.
There's
and
no
food will be less available, and that is pretty scary.
Correct.
Because we all think we all just assume it's going to continue the way it's going, where food is going to become more easily. You hear manufactured meat and other things that's being worked on, and that just make you think, well,
and that may save us.
Right.
That kind of technology may save us too. Those are the kinds of things that are maybe a computer-enhanced brain may be able to come up with even more often. Just convert a pile of dirt into a pile of meat. That would be fantastic. That was, again, back to Star Trek, right? And their food synthesizers. And if we can capture that technology, that would be amazing. I think we're a long ways from doing that, but we are capable of doing similar things, right? And that may be the key thing. There will still be a loss of landmass. There will be a shifting of population, a shifting of the weather. But I think we, with our intelligence, we're a smart species. We've made it this far. For some reason, the other four Homo sapiens that lived on the planet, 15,000 years ago, they didn't make it. We did. And maybe that says something about what we can do, in the future.
Right.
Maybe we will not go extinct. But no guarantees for any organism, right?
Right, there's no way the hell we can. And there's no way we can end on that. So people crying.
I know. But it's
no.
But it kind of comes around.
It does. And the amount of people I speak to, I haven't I haven't spoken to one smart person in a long time that was still considering that, the whole global warming thing was a hoax, as they used to say. I think I feel like that whole theme has passed. So, I mean, I haven't really followed it, to be honest, and I don't really care to get political, but it seems it's getting pretty silly at this point that there's not massive, like isn't that massive movements to say, hey, guess what? We can't ignore this anymore. It's pretty silly, if you ask me.
But you know what I love about neuroscience is that these topics influence it, and our brains influence how we respond to these topics and how they. And I think you just raised a really important point. Why don't people see and be scared about what is about to happen a very long time from now?
Right.
Years, decades. And the answer is, why didn't they see what was happening to them with cigarettes in the 60s, or cocaine in the 1880s, or, you can keep going back, or sugar in the 1990s. And the answer is that we don't have that kind of brain. We don't project that far ahead. For whatever reason, we don't have statistical brains. We don't have brains that project, I think, ourselves far enough in the future to change our behavior today for a fear that I might get lung cancer from my cigarette, because God, my cigarette makes me feel euphoric.
Right.
I think neuroscience helps explain why we are in the position we're in, and it may give us a solution, but at the moment it's making things worse. And I think and as we learn more about the brain, and I think look at it in that way, and realize we need to do something compensatory here so that we don't make these mistakes again. The more we learn about how our brain functions, maybe we'll become better at preventing these follies in the future.
Yeah, well, that's this, and then, a little bit hopeful there. So we can wrap this up. I mean, this has been really. So what's your latest book that's out? What's the last one you have two, correct?
Well, the third edition, it's sort of the updated version of Your Brain on Food came out just earlier this year. And then next year I have Your Brain on Exercise. But I have one that's been doing well. It's called The Brain, What Everyone Needs to Know. That got a huge boost from Bill Gates when he had it on his desk, reading it during a interview he gave on Netflix of what's inside Bill's brain or something like that.
I did not know that. Very cool. Very cool.
And yeah, it was like some of my students are texting me, look at this picture. Anyway, but that's been, but those are the ones I have out there. Just, I've been teaching this stuff for a long time, and by writing the books, it just lets me continue to be the teacher that I've enjoyed being. And but thanks for asking.
No, excellent. And I'll put some links to the books in the show notes so folks can find them.
All right, and thank you, Vinny. Thank you for the opportunity.
Yeah, no, absolutely.
And if you have questions or follow-up, you can email me and let me know.
Yeah, no, we'll do. I appreciate it. All right. Well, Gary, appreciate your time. Thanks so much.
My pleasure.
And that's a wrap. Hope you enjoyed it. Hope you learned something. We'll see you next time.